All right, kids, let's get through this. Here's the first question. I know you guys looked at it like what? We did this on the first day, so this surely shouldn't be an issue. What we got was we got 100 randomly. We got 100 kids, and we want to randomly select 15 of them. Uh-oh, thought I had my highlighter up. We want to randomly select 15 of them. 15 of them. And use that in order to gain or to figure out what the average of all 100 is. So we're gonna randomly select 15 by using the random number table. So I gave you the start of the random number table. So we're gonna start right here. Then the first one we're gonna pick is 7. Once you get this, you can fast forward a little bit. Once you understand what I'm saying, remember these are 0, 0, 0, 0, 0. Right, all the way through 0, 9. And then remember, since we only need 2 digits, this is really 0, 0. Should I happen to have a 0, 0. So my first one is 7. My second one I'm going to do is 67. Sorry, I was looking at the wrong one. 67 is 68. Then I'm going to go to 92, which is over here. I'm really having a hard time looking at my own chart here. Then I'm going to go to 32. Should be male student number 32 is right here. Then I'm going to go to male student number 96, which is right here. Then I'm going to go male student 03. 03 is this guy. Male student 00, so that again is number 100. Make sure you understand that. Male student number 27. Number 17. Number 67. Now 67, looks like we've already used 67, right? So I had a 67 here, and I got another 67, which I can't use that one, so I'm going to get rid of it. Next one will be 04. You can't use a number twice. And then 47. And then 43. And then 29. This is a little bit time consuming. It's kind of a pain in the neck. And then 9. See if I got into 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, one more. 74. So my last one will be 74, which is right here. So now I'm just going to write those numbers down. Those numbers are 77 plus 77 plus 62. My God, my handwriting is horrible. Actually, you know what I'm going to do? I'm just going to put them in a list and spreadsheet for myself. Let's see if I can shrink this up a little bit. Why can I not shrink this? So list and spreadsheet, I'm just going to do it this way. X. So I got 77 and 77 and 62 and 62 and 63 and 27. Oops. Not 27. 27 would be a very short person. 69, 60, 68, 59, 70, 68, 67, 73, 77, and 74. So that's all of them. I'll just come up here and run the 411 on it. Menu 411. Boom. X. And my average is 68.3. So my average would be, and you'd have to, if it's multiple choice, you don't have to show this work. But you come up here, you find the X bar. I don't know if you saw that. The X bar was 68.3. So I'm going to say, all right, the answer is, the average is 68.3. So the average male, it would be 68.3 based on this, distribution of males. That's it. That's how you do it. Remember, hopefully you remember that. If that doesn't make sense, I guess you're going to watch that again. All right, now we're going to go to number 2. I circled all the questions you want to do, that we're going to do. Let me just pause for a second. I want to make sure this recording is working fine. So it looks like we're in pretty good shape. Let me just get this a little bit bigger. All right, so let's go through this. I don't know if I got through, I think I got through all this stuff. Just remember, if you want to go back through these, that because we're breaking them up into different groups, that would be a controlled experiment. But remember, I think we talked about this in class. Hopefully you were there. I said, if I was to select the first 10 people that came in and put them in group 1, and the next 10 people that came in and put them in group 2, and the next 10 people that come in 3. So if you're the late arrival, you have no chance of being in the early group. That's not how it works. You got to take all 30, put them in one big group, or all 40, or all 50, or whatever it is, and then you got to split them up randomly. You can't just take the first 10, the first whatever. If you're watching what people are doing and you're not involved, that's an observational study. If I ask you about when you come in, you didn't have to do these, we did these in class, but if I ask you, about what's going on in your life and, I'm right in front of you, that's going to be response bias. If you don't get a whole lot of responses, that's non-response bias. But if you go out of your way to make your point known, like, if you're at Lowe's and you got, terrible service and you go up to the customer service and I demand to see the manager and you want to tell them what happened, that's voluntary response bias as opposed to non-voluntary response bias. Non-voluntary response bias, where you were asked and you just throw the survey away. You're just not going to respond at all. We didn't do this question. If we ask the 23rd person and then every 7th person after that, that's systematic. If you ask just the first 30 people, that's convenience. Oops. Standard deviation is the typical distance from the mean. All right. So I'm not sure we got through all of these. Just to make sure you understand, this one is skewed left. Left. This one is skewed, I forgot, right. Right? Skewed right. I probably should grab a different pen other than red. Skewed right. And then the rest of these 3 are symmetrical. Now remember, if it's skewed left, that means the tail goes this way, but also the mean goes this way. I'm going to do a problem in a second. Which one has the largest standard deviation? That would be this one, because you need a really big net or a really big standard deviation in order to get to that tail and in order to get to these numbers out in here. Right? So this one would have the biggest standard deviation. This one would have the smallest. But if I was to say to you, let's say I said to you that the mean was less than the median. All right, so let's say the mean is less than the median. Means follow the tail, so that would be a drawing that looked like this, where it skews off to the left. So if I said the mean is less than the median, that means the mean is on the left. That means the distribution is skewed left. If I say the mean is greater than the median, then this is going to be one that tails off this way. Mean is greater than, mean goes to the right. That means it's skewed right. You might need to know that for Monday. All right, we did this one in class. We're going to do one more of those. All right, so let's get to the meat. Civil service exam each year. Okay, so what percent of applicants were between 168 and 212? Well, I think if I take 190 and I add one standard deviation, which is 22, and I subtract 22, I get 212 and 168. So up one standard deviation and down one standard deviation is 68.2%. If I go another 22 and another 22 down, so I go another 22 up and another 22 down, that would be 95.4%. And I go another 22 up and another 22 down, that's 3 standard deviations, that's 99.7%. So this is called the empirical rule. This is called the empirical rule, right? So if I said, hey, based on the empirical rule, what percent of data is between these two numbers, and those two numbers happen to be up and down 2 standard deviations, you'd say about 95.4%. So now it's a little bit different. Now it says what percent of applicants took over 200 minutes to take the test. Well, this is a little bit different. I'm going to have to draw it up, right? 200 minutes is right here. So what took over 200 minutes, we are going to shade to the right. Let me pause for a second. I can get my z-score table up. All right, let's do this. So the mean was 190 with a standard deviation of 22. So let me get my mean of 190. and my standard deviation of 22. So I just run the z-score. Z equals x, which is 190, minus mean, which is 200, divided by 22. And I have my calculator somewhere. Where is my calculator? This one. Oh, this one's my calculator. Jeez. Home. So I'm going to do control division, 190 minus 200 divided by 22. I don't know why I put a division there. Over 22 decimal. Boom, boom, boom. There it is. Negative 0.454545. So it's actually negative, so negative 0.45. Negative. Oh, I did this backwards. See, that was cool. It's x minus mu, so it should be 200. I was trying to wonder why. Why did I get a negative? I didn't do that on purpose, but I'm glad I did. Why did I get a negative z-score when I know doggone well my number's on the right? Doesn't make any sense. So it should be positive 0.45. So I'll come over here. I go look up positive 0.45. Positive 0.45. Let's go. Let's go. This is, oh, can't do it on there. Positive 4.0, 1, 2, 3, 4, 5. That should be 3264. So if you want bonus, it's the probability that z is greater than or equal to 0.45. And I already forgot the number. I know it's 0.3 something. 4, 0, 1, 2, 3, 4, 5, 3264. All right, what percent took less than 150 minutes? Ooh, that's terrible. Less than 150 minutes. 150 minutes is off to the left. So this time I will, excuse me, I will get a z-score that's going to be negative in this case because it's off to the left. So I'm going to go, okay, oops, I forgot z. Z equals 150 minus 190 over 22. 150 minus over 22. So I get negative 1.82. Be careful with that. This is negative 1.82. So the probability that z is less than or equal to, because remember we want less than, I should have shaded. Negative 1.82 is equal to 1.80, 1.81, 1.82, 0.0344. 0.0344. Now, if I ask percent, this answer is really 3.44%. This one is really 32.64%. I don't remember what I do on the test. I'm not going to be hypercritical on that. It'll be bolded so you know which one to do. All right, so now between 170 and 210, 175 and 210. So you're getting a couple of different problems like this, just to make sure you understand how to do them. If you didn't know how to do this one, the next one's fairly similar. Try pausing the video and do it on your own. All right, don't just watch the trained monkey perform, right? The trained monkey gets tired of performing. In this case, we got 175 over here, and I got 210 here. And I want in between. All right, so I'm like, all right, 2 z-scores. I got 175 minus 190 over 22, or 210 miness 190 over 22. Now, the one on the right will be a positive z-score. The one on the left will be negative. So the first one's 175. Oops. So that's 0.68. So negative 0.68. And then the next one, I forgot what number it is, 210. And that's 0.91. Be careful with that. It's 0.91. All right, so now I go look up 0.68. 0.68 is 0.8 would be 2493. 2490 or 80? 2483. 2483. And this one, 0.91, would be 1814. 0.1814. Now, I want the part that's in the middle. Remember, when we come back, these should be pointed into the tails, right? This is 0.2483. This is 0.1814. I don't want those. So what I'm going to do, since they're on opposite sides, to get rid of those two tails, I'm just going to subtract them from 1. So the probability that negative 0.68 is less than or equal to z is less than or equal to 0.91. Again, that writing this is bonus. What I really want to see for everybody is 1, I better do this not behind my head, 1 minus 0.2483 minus 0.1814. Man, I'm running out of room. So 1 minus 0.2483 minus 0.1814. And I get 0.5703. So the answer to this question is 0.5703. Or 57%. All right, this one's a really tough one. This question's a really tough one. Since this is a exam and you get rated on speed, so a lot of you are going to do this one backwards. In order to maximize the score, the applicant must finish faster than 90%. Please understand how this problem is done. It is huge that you understand how this problem is done. So we're going to draw up a normal distribution curve. Because it is a race, this end is the best or the fastest. And this end is the worst or the slowest. So if I want to finish faster, if I need to finish faster than 90% of the people taking the test, finish the test faster than 90%. So where would the slowest 90% be? Well, the fastest would be down here. So I need to figure out what this is. This is 190. This is a standard deviation of 22. Right? Here are the 90% that are actually behind me because this is a race. So this area right here would be 0.90. I don't want that. I need to finish faster than them. So I really want this area down here, which is 0.1000, 10%. Now remember, when I give you the percentage, we don't want this one. When I give you the percentage, you got to go play as Where's Waldo. So let's go find the z-score for 0.1000. And hopefully you see it. It's right here. Why is this maximized? Get this a little bit bigger. You can see it. So 0.1003 is here, and that's 1.28. But since we're on the left, it's a z-score of negative 1.28. So I'm like, all right, let's set that equal to x, which we don't know, minus 190 divided by 22. Again, I'm on the left because it's a race, and there will be a race question on the test. So make sure you understand that speed makes a difference. So then we're going to come to our calculator. We're going to say, all right, negative 1.28 times 22 equals negative 2816. Negative 2816 equals x minus 190. And then I'm going to add 190. And I get 161.8. 161.8 is the answer. Now again, if it's a race, if I finished at 161 minutes, I finished in front of the average, which is 190, which means I'm faster than them. All right, a person whose score, with a score that lands him in the slowest 20%, well, now it's a little bit different. The slowest 20% would now be, let's put this on here, 190, standard deviation to 22. The slowest 20% is actually right here. Has a very low chance of getting hired. So the slowest 20% is right here, 0.2000. So remember, if it's a race or if it's something that's speed oriented and the faster you do, the better, then the worst is actually on the right and the best is on the left. All right, so let's go find out, play Where's Waldo. Where's 0.2000? It's right here. So that's 0.80, 1, 2, 3, 4. So my z-score is 0.84, but this time it's positive because it's on the right. I'm like, all right, what is my observed value? X minus 190. That should be a 190. Over 22. So come to my calculator, I go 0.84 times 22 18.48. 18.48 equals x minus 190. I add 190, and I get 208.5. 208.48, but that's 0.5. All right. All right. Let me see what this problem. This problem's a little bit different. So I want greater than 1520. So again, greater than, we're just going to do a normal distribution curve. I saw some really bad normal distribution curves in the last couple of days. This one is how many people, right? So the question is what percent? So we're just talking about what percent. So the average is 1450. And I'm going to lose a light again. And the standard deviation of 122. Now 1520 would be on the right. So 1520 would be over here. So I should end up with a z-score that's positive. So all right, z equals 1520 minus 1450 all over 1.22. 15.2 minus 14.5 and are divided by 1.22. So I get a z-score of 0.57. So z-score of 0.57. So again, this is the bonus part if you want, probability that z is, I should have shaded greater than 4.57. Z is greater than or equal to 0.57 is 0.57 is 2843. 0.2843. And again, if I said percentage, the answer is 28.4%. It does say what percent, 28.43%. Anything rounded properly be fine. All right, less than 13.25. So it's going to be the same normal distribution curve. Not hopefully as bad as this one. It's really hard to draw with this stupid pen. And this is 1450. And standard deviation of 1.22. And we want less than. So we want that. Let's see. Yeah. So z equals 13.25 minus 14.50 divided by 1.22. And all I do is, what did z score? Oh, I didn't do it right. 13.25. Man, 13.25 minus 14.5 all over 1.22. So negative 1.02. Negative 1.02 should come as no surprise that it's negative. It's on the left-hand side. Less than or equal to negative 1.02 is equal to 1.02. Go look that up. 1.02010. This is 00. 1.02 would be right here. 1539. So 0.1539. If it does say percent, it's 15.39%. Now between 14 and 16, so this is one on the left and one on the right. I don't know why I'm not doing, I know I do one later where they're both on the same side because that's actually on the test as well, and that's actually one of the more difficult questions. 14.5, 1.22. And on the right, we have 16. And on the left, we have 14. And we want in between. So we want this. We don't want the tails. We want this in between. So I have to run two z-scores. Man, did I not give you a lot of room for this one? Sorry about that. We got 16 minus 1450. We'll blame Mrs. Weiser for this. All divided, and then that's one z-score, and the other one is going to be 14 minus 14.5. Oh, that's terrible. Divided by 1.22. So I'm going to do both of these at the same time. So I got 16 minus 14.5 divided by 1.22. And I got 14, oops. And I got 14 minus 14.5. divided by 1.22. So I've got 1.23 1.23, and negative 0.41. So I go look up 1.2, I forgot already, 1.23, 1.20123, 1093. So that's this one, 0.1093. And then I'm going to go 0.41. That's going to be a big number. 0.40, 0.41 is 34.9. That's down here. 0.3409. That's a 4, by the way. 09. Now remember, I want the part that's in the middle, and they're on both sides. So I'm going to subtract off the tails. I'm not going to do the probability stuff. I'm just going to subtract off 0.3409 minus 0.1093. So 1 minus 0.3409 minus 0.1093 equals 54.98. So 0.5498 or 54.98%. All right, Nick Roloff said he was one of the highest paid employees. Now, if you're the highest paid, that's a good thing. We want to be, it's not a race or anything, so I want to be in the top 5.1%. Well, 5.1% is 0.0510. So he's going to be up here in the top 5%. So we want to figure out what his salary is going to be. Well, the average is $14.50 with a standard deviation of 1.22. He wants to be up in the top 5.1%. So when I give you a percentage, you get to go play Where's Waldo. So 0.50, and that's going to be 0.05. Be careful. 0.05 is going to be way up here. 0.0505. 0.051. So it's between one of these two, but this one is closer. So 1.601234. 1.64. So I get a z-score of 1.64. And again, we're looking to see what that is. So I'm like, all right, let's run the z-score. 1.64 equals the observed value x minus mu, which is 1450, divided by the standard deviation of 1.22. So I go to my calculator, take 1.64, I multiply by 1.22, and I get almost like just $2. Basically, it's just $2. Because it's money, I'm just going to do that. X minus 1450. I add 1450, and I get 1650. So Mr. Roloff will make $16.50. Alrighty. Hey guys, I know this is a long homework assignment, and I really hope that you guys are, understanding that it's important that you understand how to do all these problems. If you know how to do a problem, hopefully you've already done these on your own, and you could probably do them faster than me. So I don't know. So we got 1,000 steaks with an average weight of 12 ounces. I mean, I'm doing them. You can do them. Hopefully it's helping with a standard deviation of 0.9 ounces. They're not going to accept anything less than 10 ounces. So anything less than 10 ounces we have to get rid of. This problem is definitely on the test. So here's 10 ounces. Anything down here we reject. We're just going to get rid of it. So all right, let's run the z-score. Z equals 10 minus 12 divided by 0.9. 10 minus 12 divided by 0.9. I can't believe I just did that. Negative 0.22. Negative 2.22. So anything that's down here in the bottom, negative 2.2 standard deviations. I'm going to go look up 2.22. 2.22. There's 2.2012. So it looks like 1.0132. So I come back here, I point the tail, 0.0132. Now that's the answer to that part of the question, but the question is, how many steaks are we going to refuse? So I take this and I say, all right, I'm going to multiply 1,000 times 0.0132, and hopefully you don't need a calculator to realize, well, maybe some of you do. So you come over to your calculator, 1,000 times 0.0132, and you get 13.2 steaks. So we are going to refuse 13 steaks. It's 13.2, but we're going to refuse 13 steaks. All right, that question took a minute 50. And whatever. So the Arborian Andrews just got done working on their dude rents. The cattle they raised this past year have an average weight of 2,400 pounds with a standard deviation of 40. Boom. Let's get it on there. Normal distribution. 2,400 pounds for this cattle. And we got a standard deviation of 40 pounds. They have 700 head of cattle. And they know buyers will only take cattle that weigh over 2,400 pounds. So we want over 2,400 pounds. So we want this. There's the part that's over 2,400 pounds. So, but 2,400 is on the left. So we're gonna. It's all right. That's all right. Still gonna run the z-score. We're gonna get a negative z-score. 2,400 minus 2,450. That's negative 50 divided by 40. So, I mean, if you want to run it through, 2,400 minus 2,450 divided by 40, and you get 1.25. It's negative 1.25. Negative 1.25. And we expected it to be negative. It was on the left. So we go over here and look up 1.25. 1.20, 1, 2, 3, 4, 5. It's 1056 again. Now remember, when you come back, point to the tail. 0.1056. Now we don't want that. It's pointing to an area that we want. We want the rest of it. So the rest of it is found by doing 1 minus 0.1056. So you do 1 minus 0.1056, and you get 0.89. So this percentage that we actually want is 0.8944. Now let's see if that answers the question. How many steer will they sell? Well, there were 700 cattle, or 700 head of steer, or whatever the hell they call them. I'm not a farmer. Sorry, farmer people. So you're going to take 700, and you're going to multiply by 0.8944. So I'm just going to take this number and multiply by 700. And I'm going to sell 626.08. So I'm going to sell 628 cattle. All right, so this one is definitely on your test. Make sure you understand it. The Fisherman Fair just discovered a large blue whale. The estimated blue whale is discovered to weigh, so this is the whale, and it weighs in at, they just discovered a whale. Oh wait, what do we know about whales? Blue whales are known to have an average of 170,000 pounds with a mean weight of 13,000 pounds. And we found a big, ginormous whale weighing 204,000 pounds. And we also got a grizzly bear. Our bear, we know that the mean height of a bear is 600 pounds with a standard deviation of 22. What does a bear have to weigh in order to be equally as big in the bear population as this big, ginormous whale is in the whale population? And the very simplest way to do that is just through z-scores. So we're going to say, all right, z equals 204,000 minus 170,000 divided by 13,000. Now, you do not want to round this. So whatever you get, do not round it. I warn you, if you round it on the test, you're probably going to get it wrong. I forgot what it is. 170,000 divided by 13,000. And you get a z-score of 2.615, 2.61538. That should be enough. All right, so that means that the bears have to have that same exact z-score. So I'm going to take 2.61538, and I'm going to set that equal to, well, we don't know what x is, so it's x minus 600 divided by 22. So I already have that z-score in my calculator, so I'm just going to take it. See, it's unrounded there, and I'm just going to hit times 22, because that way I don't have to type it in, make a mistake typing it in. And I get 57.538. So 57.538, that should be good enough, equals x minus 600. So now I'm just going to add 600. And I get 657. Now, what do we got? I should have said to the nearest pound or something like that. So let's round this to the nearest pound. 658 pounds. So X equals 658 pounds. Oh, I'm recording. Oh, the mean weight of 18-year-old boys is normally distributed with a standard deviation of 7.5 pounds. What is their mean weight if 22% of them? Okay, so we're looking for the mean this time. So we don't know mu. But we know that 21% of them, oh, we have a standard deviation of 7.5. But we know 21% of them weigh more than 175 pounds. So we know that 50% weigh more than this. So 21% must be up here somewhere, where this is 21%, or 0.2100. And we know that is a weight of 170 pounds. So 21% of them weigh over 170 pounds. All right, so we got it. When I give you the percentage, you got to play Where's Waldo. So Where's Waldo? 0.2100. This is 0.2119. This is 0.20. This one's a little bit closer. So this is 0.801, 0.81. So we get a z-score of 0.81. And we're going to take that 0.81 and we're going to set it equal to our observed value of 170 minus the mu, which is what we're looking for, divided by 7.5. So come back over to my calculator, 0.81 times 7.5, and I get 6.075. So 6.075 equals 170 minus mu. I'm going to subtract 170. And I get negative 163, negative 163.925 equals negative mu. Don't need the negatives. And to the nearest tenth of a pound, 163.9 is the average. All right, this one I think we're going to look for the standard deviation. So same kind of a problem, same kind of an idea. Mean weight of 1,400. In this case, we're looking for the standard deviation. If 18.1% of the bomb's effective radius is over 1750, so 1750 would obviously be on this side, and it said 18.1%, well, that's this. So this is 18.1% or 0.1810. All right, so we got to look that up. Z equals 0.1810. 17. There we go. There, that's probably closest to 0.1810. So that's 0.90, 0.91. So in this case, our z-score is 0.91. So all right, 0.91 equals x, which is 1750, minus mu, which is 1400, divided by our standard deviation. We're still going to cross multiply, so you get 0.91 equals, times standard deviation equals 350. All right, I just subtracted those. And then I just divide by 0.91. I don't know why I just put R. Standard deviation is 350 divided by 0.91. And 384.6. 384.6. So that must be my standard deviation. All right, that's it for that piece. Let me stop for a second. Let me go to the other ones. All right, let's get to the other one, the final one. There's, I think, 6 more questions, right? 1, 2, 3, 4, 5, 6. Oh, and one of them's the big one. One of them's the big 20% question. All right, let's see what we got here. Sam has been reaching MLS goalies statistics and found that goals against average was 2.33 with a standard deviation of 2.05. Should have said normally distributed. I hope it says it in there somewhere. I hate it when I forget to put normally distributed. All right, it should have said that. I apologize. So we got an average of 2.33 goals against with a standard deviation of 0.205. Now, for those of you that are struggling with a little bit of sports knowledge, less goals is better. So fewer goals. So the better goalies are down here. This is where the best is, and this is where the worst is. So this is kind of like a race question where best is on the left, worst is on the right, right? Because if you want low goals against you. So it said a women's national team goalie must rank in the top 8.5% of all goalies in relationship to their goals average against. So in order to be in the top 8.5%, you actually have to be down here, which we don't know. So we want to find that number where we are in the top 8.5%. That's the top. So that's 0.0850. So since I gave you the percentage, you got to go find the z-score of 0.0850. 0850, 09, 0869. Here we go. Here's 0.0853. So that's 1.37. 1.37. 1.37. Now that's my z-score. That's not what I'm looking for. That's the z-score. So now I got to put it in the z-score formula. 1.37 equals x minus 2.33 divided by 0.205. Like, all right. 1.37. Remember, we're going to cross multiply times 0.205 equals 0.2808. Don't round yet. 0.28085, I believe it said, right? Equals x minus 2.33. So we're going to... Ooh, I've got a major problem. I did not think. And I was just about... Here's what's going to happen. I was going to go like this. I was going to add 2.33. But look at that. I got 2.6, but I'm on the left side. That doesn't make any sense. So now, intuitively, I'm like, oh, I made a mistake. And again, I didn't do this on purpose. It's a total mistake. But I looked at it and go, that doesn't make sense. I'm like, oh, yeah, the z-score should be negative 0.137. So I'm going to come back up here and change this to negative. And then press enter. And now add 2.33. So this should be negative. And I get, 2.049. So 2.049 equals x. Now I said round to the nearest hundredth of a goal, so that's 2.05. So she has to have a goals against average of 2.05, which is better than 2.33. Be careful with that. Matt and Logan are having a debate about who's the best attacker in lacrosse. Of course, it turned into a battle. Let's do what we got. What do we know is the average shot for... so, by the way, Matt is the boy. I don't know if I put that in there. Logan is the girl. It's Logan Hibbert and Matt. I forgot who the Matt boy was. So, a girl attacker chosen. Average shots for the girls lacrosse team. The average shots is 12.6 with a standard deviation of 2.2. And the boys team average is 8.6 shots with a standard deviation of 1.9. Now Logan told Matt that she averaged 15.2 shots. 15.2. So clearly she's better than the average. So the question is, what does Logan have to get in order to be equal or better than her? So we want to be equal. What is the minimum number of shots on goal, round to the nearest tenth, should he tell her in order to win the argument? Okay, so let's see. This is going to be a little tricky question. So first thing we're going to do is figure out the z-scores. Z equals, because the only way to do this is through z-scores, 15.2 minus 12.6 divided by 2.2. So 15.2 minus 12.6 all over 2.2. So Logan's z-score is 1.1818. So Logan's z-score is 1.18 repeating. Don't round. So now we're going to say, okay, he's got to have the same or better z-score. So 1.18 repeating equals x, which we don't know, minus 8.6 divided by 1.9. So again, I've already got this number in here. I'm just going to hit times 1.9. And I get 2.24545. So 2.245 repeating equals x minus 8.6. So now I'm going to add 8.6, and I get 10.845. So x equals 10.845. Now it said round to the nearest tenth. Here's the tricky part. If you rounded this to the nearest tenth, and I don't trick you like this on the test, I promise you, 10.8, he actually does worse than her. So in order to actually answer this question, and this question is tricky, the answer would be 10.9, because 10.8 is a little less, 10.9 is a little more, so he would have to tell her that he averages 10.9 shots per game. I promise you I don't trick you that on the way on the test. All right, kids, we're getting close. The Dilbert Delight Company has been designing glazed donuts for the Kidder Corporation. Ms. Kidder has begun to believe that the size of the donuts has been steadily decreasing. Mr. Dilbert assures her that this is simply not true. He tells her that the glazed donuts he makes average 28 grams with a standard deviation of 1.9 grams. Ms. Kidder has told him that she's going to inspect the next shipment of 1,500 donuts, and anything less than 24.5 grams she's going to reject. So, all right, let's do it. Average of 28 with a standard deviation of 1.9. And she will reject anything less than 24.5. So we're going to reject anything less than 24.5. All right, so run the z-score. Z equals 28 minus 24.5 divided by 1.9. I don't know why I put 0.19, 1.9. 28 minus 24.5. Totally did that backwards, because I'm going to end up with a positive z-score. That doesn't make sense, right? And so when I saw that I'm going to end up with a positive z-score, I realized, oh yeah, I did it backwards, because I should end up with a negative z-score. Sorry, kids. Got home at like 1 a.m. last night. I didn't sleep much. Minus 20. That's my excuse. I'm sticking with it, by the way. So we're going to do this backwards. 24. I'm going to do it the right way. Minus 28 divided by 1.9. So we get a z-score of negative 1.84. Negative 1.84. So I'm like, all right. Let's go look that. That's going to give us a percentage down here. 1.84. 1.80. 1, 2, 3, 4. So 0.0329, 0.0329, that's what I want, so I'm going to keep that. But that's not the answer to the question. The answer to the question is how many of these donuts are we going to reject? So we take the 1,500, we multiply by 0.0329, 0.0329 times 1,500, and we get 49.35. So we will reject 49 donuts. 49.35, we will reject 49 donuts. All right. A friend of mine is looking at freshman level calculus course in order to determine. This, by the way, is one of the trickier questions on the test, so make sure you're paying attention. In particular class, there are 350 students. The professor had a very controversial way of selecting grades, blah, blah, blah. How many students were scored to B+? So we're looking for this one right here. What percent scored in the B+ range? Or no, it says how many students were scored in the B+ range. All right, so let's draw this up. The average was 84.5 with a standard deviation of, was it 5.4? Why do I keep putting 4s when I know I can't write 4s? 5.4. So this is an 84.5 with a standard deviation of 5.4. Now, 91 is somewhere over here, and 94 is right here. So I want all of this. So this is a little bit tricky. You're going to have to run 2 z-scores. Give me plenty of room to work on these. So remember, it's always observed minus mu. So 91 minus 94 over 5.4. And 94, oh my God, it's been a long day. 91 minus the mean, which is 84.5 over 5.4, and then 94 minus 84.5 over 5.4. By the way, if you find any mistake within my thing and you call me out on it, I'll give you bonus points on the test if I made any mistake today. Not that I corrected. It's got to be a mistake that I didn't correct. All right, so control division, 91 minus 84 point, I don't remember, 5 divided by 5.4. Boom. First z-score, 1.20. Now we want 94. And I get 1.76. All right, so now I'm going to go look these up. 1.20. 1.20 would be right here. So that's 0.1130. So that's this one. From here over is 0.1120. I believe that was it. Nope. 0.1131. What was I looking at? 1.21. No, it's 1.20. So this is 1.20. Is that right? 1.20. So 1.20 is actually this one. Don't grab the wrong one. 0.1151. 0.1151. Oh, you're all just thinking I made a mistake. Bonus. All right, now we're going to look up this one, which is 1.76. So here's 1.70. 1, 2, 3, 4, 5, 6. So that's 0.0392. But these are on the same side. So this is all 0.1151, and this is 0.10392. So what I want to simply do is subtract them. So 0.1151 minus 0.0392. 0.0759. So 0.0759. But that's not the answer to the question. The question said how many students received. Well, if we got 350 students, we're going to take this number, 350, and we're going to multiply by 0.0759. So I get 26.56. So 26.56. So the answer is 27 students. Just round it. Just round it. 27 students. All right, Mr. Dufo knows that the dental insurance company has to charge. Top 9% would have to pay full price. The next 25% of the people would pay 75% of the bill. Next 22% have to pay half their bill. The next 29% would pay 25%. Could I make this problem any more dumb? And the bottom 15% would have to pay nothing. If the average household incomes are approximately normally distributed with the average of 65,000 and standard deviation of that, what household would have to pay full price? Well, full price is the top 9%. So it's this average of 65,000 with a standard deviation of 8,200. And the top 9%, whatever that is, that's 0.0900, has to pay full price. It said the top 9% pay full price. All right, so I gave you 9%, so you got to go play Where's Waldo, 0.09. 09. Where the heck is 09? 0918. 09, here it is, 0901. So that's 1.301234. So 1.34. So my z equals 1.34. Now it's positive because I'm on the top end. 1.34. So I go 1.34 equals x minus 65,000 divided by 8,200. So 1.34 times 8,200, 10,988 equals x minus 65,000, add 65,000, And I get 75,988. 75,988 equals X. What income would have to pay less than half of their bill? This is where the jerk question comes in. 65,000. Standard deviation of 8,200. I think I missed a zero. So this less than half. Less than half. So let's see. 22% would pay half. We're not going to include those. We're not including those. So we're going to include everything else. So the next 29% would have to pay 25%. And the bottom 50% pay nothing. Or the bottom 15%. So the bottom 15% pay nothing. And the next 29% pay only 25%. So those are the only two that pay less than half. So that's 29% and 15%. I do not give you a hard question like this on the test. So let's see. We got 15% and we got 29%. So if I add those together, I get what? 44%. So the bottom 44%, 15 and 29, that's 30, 44. So this is 0.44. So the bottom 44% do not pay nothing or pay less than half. So I go look up 0.44. Here it is, 0.4404. So that's 0.1012345. 0.15. So I z-score equal to 0.15. So all right, 0.15 equals x minus 65,000 times 8,200. Oh, it's on the left side, it's negative. It's on the left side, it's negative. I don't know if I said this or not, but it's on the left side, so it's negative. Otherwise, I would get a weird answer. Times 8,200. So negative 1230 equals x minus 65,000. Then you add 65,000 equals 63,770. So anything less than 63,777 plays less than 25%. Otherwise, it's just not true, but I'm missing something. There's a page missing. All right, so we're on the last question. I cheated a little bit. I already got this data in. The nice thing is you don't have to type it in. The one on the test does have, I think, 40 numbers on it, so you're going to want to make sure you put those in accurately. I already typed these in. So there they are. I called it UBIT 9 instead of Unit 9. So I've typed in all 60 of them. Hopefully I've typed them in correctly. I'm pretty sure I did. We'll put that there. So you maybe don't have this calculator at home, but at least I did this math for you. You can come here and do this stuff. So then we're going to run the 4-1 run, right? We want to get our information. So we hit menu 4-1-1. We have one list. I called my list X. Now, we're going to put all this pertinent information right in here. So my X bar is 50.88. We're looking at some income levels. So this is a sample. So I'm going to use SX, which is through 10.89. So 10.89. As soon as I'm done with that, I'm going to do my 5-number summary, which is min to max. I'll expect to see this work in here somewhere. Oh, I don't want to. Oh, I gave you plenty of space. All right, min to max, I gave you plenty of space for this. So the 5-number summary. Pull off the 5-number summary. So we get min is 25.5. The Q1 is 44.25. The median is 52.05. The Q3 is 58. And the max is 81. Then we're going to go to IQR. IQR, you'll remember, is Q3 minus Q1. So I'm going to subtract these two. Now don't get rid of your data here. Just go home and choose calculator. So we're going to do 58 minus 44.25. And I get 13.75. Now I'm going to do my outliers. So that's Q1 minus 1.5 IQR. Let's do that first. So that's 44.5 minus 1.5 times 13.75. Oops. How did I get 114 in there? 23.625. Shoot. So 23.625. I thought I had outliers on this one. Q3 plus 1.5 times IQR. Oh, times 13.75. So 58 plus this time. My goodness, there's no outliers in this one either. 78.63. So notice my smallest is 25.5 and my biggest is 81. There aren't any outliers. If there were outliers, you would just circle them and then use them for later. All right, let's do our box plot. We got to get from what? 20 to 80, basically. So 20, nice uniform, 30, 40, 50, 60, 70, 80. Fairly uniform scale. It's not perfect. I'm not going to put a ruler on it. But I am going to make sure it's relatively neat. The Q1 and Q3 give me my box. So that's 44.25 and 58. So 44.25 up to 58 is my box. My median is 52.05, so that turns out to be almost in the middle. Max is 81. And my min was 25.5. And income levels in New York. Income levels. Good enough. All right. So next thing I asked you to create an Instagram of bar widths of $5,000. So our lowest is 25,000 and our highest is 81,000. So why don't we just go from, this is not fun. Shoot. I don't like this question. So we're going to go from 25,000 to 29,999, 30,000 to. So really we're going to go from 25 to 29.9, 30 to 34.9, 35, 40, 40, 50, 60, no, 45, 50, 55, 60. My goodness, why did I do this? 65, 70. I think this is not the question I wanted to put in here, so I'm apologizing. I meant to put a different question in here. So 25 to 29.99. We got 25 to 29.99. So that would be 2. 2 in this range. 30 to 34.99. So 30 to 34. So that would be 3. 35 to 39. Let's see. 35 to 39. So that'd be 4. 40 to 44. Well, that's a lot. 40 to 44.9. So it's 1, 2, 3, 4, 5, 6, 7. Wait, no, 35. 30 to 35 was, oh, wait. This is 4. This is 7. 45 to 49. Told you I'm tired. 45 to 49. All these. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. 50 to 55. Not up to 55. Oops. Don't include that last one. To here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. $55 to $60. Yes, this is a pain to do that. $55 to $60. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 60 to 65. 5. 68, 65 to 70 would be 3. Why is 81 not an outlier? Oh, 81 is an outlier. Oh, yeah. There is an outlier. This one is not an outlier, but I thought, this isn't the question I wanted to do. I don't know what the question is I want to do, but 81 is an outlier, right? Because it's up here. So then we got this weird one that's way up here from 80 to 85. So this is 1. We do have one weird outlier. All right, so I count these boxes. I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 25, 26, 27, 28. So there's 30, and I got to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I got to make every, doggone it. This is why I know this isn't the one I wanted to do. I know it had less numbers too, which is kind of a pain. I'm sorry about that. We're going to have to do 2. Pick the wrong pen. So I'm going to do a break. I don't think I'm going to put all of these in. I think you guys get this. Or you guys can just freeze it or just fast forward past all this. I'll put it in, but fast forward past all this because I'm not going to be able to write these all in here. This is 25 to 29, 9, 30 to 34.9, 35 to 39.9. So please just fast forward past all this. 40 to 44.9, 45 to 49.5. I hate 4s. 50 to 54.9. I got a 4 in every one of them too. 60 to 64.9, 70. Nope. 65 to 69.9, 70 to 74.9. This is annoying. 75 to, I apologize for this one. Definitely blaming Miss Wiza. 80 to 84.9, 85 to, oh, we're done. All right, and the highest one I had to get to, I think, was 14, correct? So I don't know how many boxes here. I'm just going to make every one of them 1. So 2, 4, 6, 8, 10, 12, 14. Now there's zero chance of me being able to draw these. I'm just going to tell you that right now. It's going to be a crap show right now. First one is 2. Some of these will go okay. Definitely missed that. And then 3. Definitely should not be using this color. And then 4. And then 7. Sorry about that. And then 9. Then 12. Oh yeah, look at that line. That's crazy good. And then 14. Oh, I forgot one. 55 to 59.5, 60 to 64.5, 65 to 69.5. I thought that went fast. 70 to 74.9, 75 to 75.9, and 80 to 85.9. Okay, that's better. All right, so what are we on then? 55. 55 should be 14. Oh my God, this is going to be so bad. I just cannot draw straight. Hopefully my shading will be good. And then the next one should be 5. And then 3. And then 1 way out here. All right, so I can't really shade. Let me try shading with one of these. You don't have to shade unless you're bored. All right, make sure your graph does not look like this. All right, so these are what? These are household incomes, right? So these are household incomes. You got to put income down here. Income. Frequency goes over here. Then title is New York State household incomes. Household incomes. The good news is I'm going to type the rest of this, I think. All right, so now we're going to use socks to describe this thing, and then we're done. Socks. Center shape sprayed outlets. I think I can type on here. All right, so if you look at this distribution, hopefully you see that this distribution is skewed left. So let's see if I can type. Oh my God, why is it coming up like that color? Maybe I'll type it here. The shape of the distribution is skewed left, period. The center of the distribution as represented by the, remember we're going to use median, is, totally forgot, 52.05. 52.05. 2 sentences done. The spread, 3 of them done actually. The spread of the distribution, no, 2 of them. As represented by the IQR is 13.75. 13.75. If this distribution has any outliers, they would be less than 23.6 and 78.63. I'm not going to remember that. 23.6 and 78.63. point. I told you I was going to forget it. 6. Since 81 is outside this range, it is an outlier. Boom. That's it. That's all she wrote. A little help on the bonus. Bonus, you're going to have a half-life question, and you're going to have one like this. Tangent of 330 times the cotangent of 210 times the secant of 240 times, I don't know, cotangent of 270. And I want the exact value. So that's first bonus. The second bonus is going to be a half-life. That's it, kids. I'm done. I'm wiped out. It's Mother's Day. Go tell your parents tell your mom you love her and be nice to her tomorrow.